everyone, and welcome to this video about learning theory. Here we are going to take a closer look at cognitivism. Cognitivism is a broader field, but here we will highlight the parts that are relevant for learning and education. So let's start off with the overview slide. Cognitivism started out in the 50s as an opposition to behaviorism. Learning is here seen as information processing and as an inner construct. It is about how information is represented in our mind, how it's stored, processed, and used. A lot of the time, it uses a computer metaphor when it talks about how learning works. And here we have a lot of research about memory. And key figures are Piaget and Miller. So, cognitivism focuses on how information processing happens in the mind, how it's received, organized, stored, and retrieved. Before, it used to talk more about gaining knowledge, but now it talks more about constructing knowledge. And learning is seen as an active process here, something we do. So, when we compare cognitivism and behaviorism, we can see that while behaviorism sees learning as a change in behavior through external events, cognitivism sees it as that you learn, construct knowledge that then can affect your behavior. So the way you think about something is what is important, not the behavior in itself. Cognitivists can still use observation of behavioral changes as part of their research, but the changes in behavior is seen as an indication of what is going on in the mind. So, for example, when playing a role-playing game, you and your party are on your way to a quest in unknown lands. And one late night, you meet a group of creatures that attack you. They are of a species that you have never encountered before. They look like some kind of an animal-droid hybrid. Since you see cables and tech parts, you use lightning magic to try to short-circuit them. And it seems to work. So you move on and you find a village. After talking to the locals, you learn more about the species. And one of the things you learn is that they are weak against bright light, and that is why it works to use lightning, not because it would make them short-circuit. The next time you encounter them, you use lightning again. Looking at this from a behaviorist point of view, we have a stimuli that triggers a response. In this case, the creature triggers the response, use lightning. According to the more extreme behaviorists, you wouldn't have learned anything, since your response to the stimuli is the same both times. But according to cognitivism, you have learned something since you thought about it in a new way to make the decision to use lightning this time around. Someone you should have heard about when talking about cognitivism is Jean Piaget. Here you have some important theories and concepts that he came up with. Stage theory of cognitive development. This is the idea that everyone develops in the same 4 stages that happens in a sequential order. And that when you reach a certain stage, then you can learn new things that you couldn't before. We won't go any deeper into that here, but some of his other concepts we will look a bit closer at now, and these are organizing and schema, equilibrium, and the adaptation process that contains assimilation and accommodation. But let's take them one step at a time. We start with organizing. Piaget described how we learn and organize things in patterns in our brains. He called these patterns schemas. A schema can be very, very small and specific, like how to roll dice, or more general, like role-playing games. If the information we get in match the existing schemas and there is a balance, then we reach what he called equilibrium. If there is an imbalance, we get uncomfortable and get an emotion we don't really like, and this motivates us to try to fix this. So how do we then learn and get new things into the schemas? This is done through the adaptation process, according to Piaget. As our world isn't constant but changing, we need to be able to adapt to our surroundings. Piaget talked about 2 ways that this can happen. Assimilation, where new information is linked into a pattern that is already established. So we assimilate the new information into an existing schema. The first time, for example, we see a die with 20 sides instead of 6, like we are more used to, we might still recognize that it is a die. There are enough parts that match what we already have in a schema, so we can just add it. But sometimes when we see new things, we misread them and put them in the wrong schema. For example, someone encountering a role-playing game about vampires in a printed form. And they have a schema for games, but that relates to digital games and to board games. This doesn't match that at all. But it does match the schema they have for fantasy fiction books, so they add it there. They assimilate the information. Then we have accommodation, and that is when the information doesn't fit in a schema that we already have, we change the structure of the schema. So instead of just adding it to the system, we adapt the system. And adapting the schema for game to not only entail digital games or board games, but to also include role-playing games that could come in the form of a book. Other theories have expanded on Piaget's adaptation process. For example, Thomas Nissen that talked about cumulative learning, about adding isolated information that isn't part of anything else, so creating a new freestanding schema. And this happens mostly during your first years of life. That's when you start adding new ones. Then we have transformative learning by Jack Messerov and others. Here we talk about changes that not only update a schema, like in accommodation, but when many central schemas are restructured at once. It's about learning that affects your identity. So an example of transformational learning could be if you are going to a LARP where you play a leader character and you realize you are actually good at leading people. And this then changes how you see yourself, and you start applying this to many parts of your life outside of the LARP, like at work, in your role as a parent, and so on. Now we are going to talk a bit about memory and how that works. So we have the long-term memory, where we store things, and we have the working memory that handles executive functions, is important for reasoning, planning, problem solving, and it's the guidance of decision-making and behaviors. It also combines the new information with our previous knowledge. So the working memory is also what kicks in when you are trying to remember or work with things for a short period of time, like when you repeat the character names of the role-playing group over and over again in your head to try to remember them. Older models sometimes talk about short-term memory. Short-term memory was thought of as a simple type of temporary storage, but now we know that we can actually use and manipulate the things we hold in our memory, so we can work with it. Therefore, we call it working memory. There are also models today that think of the working memory to be a part of the long-term memory. We also have something called cognitive load. Cognitive load is the amount of information that the working memory can hold at one time. So the general process would be that information passes into your working memory, where it is either processed or discarded. And when your brain processes the information, it categorizes it and moves it into the long-term memory, where it's stored in schemas. And now this leads us to George Armitage Miller. He is known for his work on the capacity of the working memory, or at the time when he wrote it, the short-term memory. He came up with what is sometimes referred to as Miller's Law in his paper that is called The Magical Number 7 plus or minus 2, Some Limits of Our Capacity for Processing Information. When we get a stimuli input that needs to be processed in the working memory, his theory was that there are a limited number of slots, 7 plus minus 2, and those slots would be the limit for how many things we can process at the same time. And his theory is supported by psychological research. For example, when I'm playing a Star Wars role-playing game and I'm trying to learn what dice to use to get my correct dice pool when using the Force to fight something, I need to remember what values that are relevant, what those numbers are, what modifiers I might want to add, and so on. And each of these things will take up a slot. But why then is it harder when learning a new system than it is later? Well, there are ways we can handle this. We can bundle things together into a chunk. A chunk is the largest meaningful unit in the presented material that the person recognizes. Thus, what counts as a chunk depends on the knowledge of the person being tested. So, for instance, a word is a single chunk for a speaker of the language, but it is many chunks for someone who is totally unfamiliar with that language and then sees the word as a collection of phonetic segments. Or for Star Wars, instead of all the steps that had been there, for someone who's played it before, they can chunk it together to force roll, and then it just takes one slot for them. We will talk more about this in the video Learning in Praxis, where we will go into cognitive concepts like cognitive load, resistance against learning, transfer, and much more. Thank you for listening, and I hope to see you in the next video where we will talk more about this.